It is commutative property, law of property. Let's continue. Then A union B union C is equal to A union B union C. It is associative property, and A union phi is equal to A, and A union U is equal to U. You know that U means universal set. That means A is a subset of U. So it is also possible that if A is a subset of B, then A union B will always be B. Let's do some problems. Sania, can you read the question?
Let A be the sets containing elements 1, 3, 4, 6, 7, and B be a set containing elements 1, 2, 3, 7, 8, 9. Find A union B.
Srihari, can you answer the question?
Then it will be 1, 2, 3, 1, 2, 3, 4, 6, 7, 8, and 9.
Good. It is set of 1, 2, 3, 4, 6, 7, 8, and 9. Second question is let set A is equal to set of x such that x is a natural number and 3 is less than or equal to x less than 7, and B is equal to set of x such that x is a natural number and 4 less than x less than 9. Find A union B. Emmanuel, can you give me the answer? Emmanuel,
Once more.
let A is equal to set of x such that x is a natural number and 3 less than or equal to x less than 7, and B is equal to set of x such that x is a natural number and 4 is less than x less than 9. Find A union B.
3, 4, 5, 6, 7, 8, 9.
3, 4, 5, 6, 7, 8, 9. Correct. Let's now go to intersection of sets. Intersection of two sets A and B means that it is a set which contains the common elements in both A and B. For example, let's take a previous set. Set A is equal to 1, 3, 4, 6, 7, 8, and set B is equal to 1, 2, 4, 5, 9. Then A intersect B means set 1, 4, 7. Only the common in both. It is denoted by A intersection. It's a symbol which it's like U upside down. U upside down. In set builder form, we represent it as set of x such that x is in A and x is in B. We use the word and in intersection, and or in union of sets. It is very important to use those two words. When an element of a set belongs to two or more sets, then we say that the set will intersect. Okay. The properties of intersection of sets. A intercept B is equal to B intercept A. It is a commutative property, and A intercept B intercept C is equal to A intercept B intercept C. It is the associative property, and A intercept phi is equal to phi. A intercept U universal set is equal to A, and A intercept B union C is equal to A intercept B union A intercept C. It is the distributive law principle property. If A intercept B is equal to phi, then we call set A and B are disjoint sets. They are called disjoint sets. Let's solve some problems. Ashwin Binil, can you read the question?
Let A is equal to 2, 4, 6, 8, 9, and B is equal to 1, 4, 6, 7, 9, 13. Find A in B.
Answer. Ashwin?
Oh, to me?
Yes. Ashwin?
1 minute, 1 minute. I have net problem. 4, 6, and 9.
Good.
Thank you.
That's it. A intercept B is equal to 4, 6, and 9. Next question. If A is equal, set A is equal to set of 1, 2, 3, 5, 8, and 13. B is equal to 2, 5, 6, 10, and 13. And C is equal to 2, 3, 5, 8, 12. Find A intercept C. 2, A intercept B intercept C. 3, A intercept B union C. Adul, answer the first question.
Set of 2, 3, 5, 8.
Set of 2, 3, and 5. Next question.
And 8.
8. Aparna, answer the second question. Aparna?
Yeah, 1 second. Two and 5.
2 and 5. Good. And Muhammad Adim, answer the third question. Adim? Aditya Siraj, answer the third question. Aditya?
Wait a minute, I will see. Two, 3, 5, 8, 12.
That's all. There is one more element. Aditya?
Okay. 9. Is it not 9?
Not 9, it's 13. Aditya, can you follow me?
Yes.
The elements are 2, 3, 5, 8, 12, and 13. Okay, that's all for today. I hope you all have understood. Do you have any doubts?
No.
Okay then, thank you.
Okay, next I call Sania. You can start, Sania.
A very warm, pleasant good afternoon to everyone. My name is Sanya, and today we'll be dealing with some questions related to limits. Ma'am, am I the host?
Yes, you can do. Yes, you can start. You can start sharing.
Can you see the board? No? Question we are dealing with is the limit extending to 3, and they are given the value here is x into x plus 1. So the limit is extending to 3 here. So instead of x, we can put the value of 3. So x into x plus 1 will be 3 into 3 plus 1. So the limit extending to 3 will be 3 into 4, which is 12. I guess no one have any doubt in the first question. Is it? So the second question is the limit extending to 1 where x square plus 1 by x plus 100. So like the previous question, instead of x, it is x extending to 1. So we can give x the value 1. So it will become 1 square it's 1. So 1 plus 1 divided by 1 plus 100. So the limit extending to 1 will be 2 by 101. I hope it's clear. Abarna, can you read the third question?
Yeah, the limit extending to 2, where x cube minus 4x square plus 4x divided by x square minus 4.
Okay, Abarna, thank you. So like the previous questions, if we like give x the value of 2, it will become 2 cube, that is 8, minus 4 into 2 square, that is 4 into 4, it will become minus 16. Plus 4 into x, it will be 4 into 2, plus 8 by x square, that is 2 square, 4 minus 4, we will get the value 0 by 0. So 0 by 0 or any number by 0, it is an indeterminate form. So we try to avoid this form by factorization or by any other method. So here, as you can see, x cube minus 4x square plus 4x, we have x common in these. So we take the x outside. So it becomes x into x square minus 4x plus 4. If you look at the denominator, it's x square minus 4. 4 can be 2 square. So it's in the form a square minus b square. And you can see the x square minus 4x plus 4. It is also in the form a square minus 2ab plus b square. So we can write it as x minus 2 the whole square. So we get limit extending to 2 x into x minus 2 whole square by x plus 2 into x minus 2. A square minus b square form. Then we can cancel x square minus x minus 2 because it is there in the denominator and numerator. So we get x limit x tending to 2 as x into x minus 2 by x plus 2. Aishwarya, can you give the final answer?
Final answer is 0.
Why didn't we take the Shivani? Can you tell why didn't we substitute 2 for the x like we did for the previous questions? Shivani? Shivani, are you there? Aryan? Can you tell why didn't we substitute 2 instead of x like the previous questions? Hello, can you hear me?
Sania, you called some other. Aryan is not here. Okay, you called some other. Aryan is there. Aryan?
Now I have network issues. I am hearing everything full cut.
Okay. Then you call.
Nia, can you tell why didn't we substitute 2 instead of x like the previous questions?
If we give 2 as the value, we get 0.
I can't, we take 0.
We get 0.
So what is the problem if we get 0?
It's not defined.
Okay. That's it for today. Thank you all.
Okay, children. Okay, both of you, Rijas and Sania, you did well. Okay, give them a clap, children. Unmute and give it. Okay, it's nice. You did very well. Okay, one thing I want to say, it was an interactive session. Can you give?
Yes, ma'am.
It was an interactive session. Okay, they asked questions. Yes or no? So everyone was keenly observing. Will the next question will it be pointing to me? That is going on. That was happening. Okay, it was good. Then Sania, she started the class and she did it in a slow and steady manner, not in a running piece. Okay, she did very well. Okay, both of you did well. Okay, you did the PowerPoint presentation. Okay, I appreciate you for your efforts. All the 4 children, those who, okay, you did well. Atul, once again, I appreciate all the children. Karthik, Atul, the other 2, Sania and Rijas. Rijas, he is a newcomer, but he did well. Where is Rijas? I can't see him. Rijas? Yes, okay. Okay. So listen, so this set theory, for your half yearly exam, we have set theory. So for the half yearly, we will not be revising it again. Now they have given the concept. Karthik gave all the types, and here Rijas, he explained the operations on sets. So we will not be revising that topic again. Okay. Now what about the limits? Is it clear how to find the limits of rational functions? Is it okay? How about find the limits of rational functions? Is it clear, children?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. So now let's write down. Let's try with the next other question. Few more questions. Write down. Okay, children, write the next question. If f of x is equal to modulus of x plus 1, modulus of x plus 1, where x less than 0, 0 if x is equal to 0, and modulus of x minus 1 if x is greater than 0. Modulus of x minus 1 is greater than 0. For what value of a, for what value of a does, for what value of a does limit extending to a of f of x exist? For what value of a does limit extending to a of f of x exist? For what value of a does limit extending to a of f of x will exist? Listen, children, here we are given with modulus function. Can you recall what is meant by modulus function? How modulus function is defined? Modulus of x is, Michael, modulus of x is, how you will be defining modulus of x? Recall and tell me. Gayatri, can you give, how will you define modulus of x? Will you define modulus of x? Modulus of x is minus x.
X when x is less than 0.
Very good.
And it's x when x is greater than 0.
And equal to 0. So you'll be including 0 also here, isn't it? So this is our function f of x. Listen, children, this question is a different question. Here we are not asked to find the limit. Here what is asked? At which point and all you'll be able to find the limits? For which values of x we will be able to find the limits? Okay, that is the question asked. Okay, so if a question is asked like this, what you have to check is, here you have to check at which point the function is divided, at which point the function is splitted. If you look at here, for less than 0, it is modulus of x plus 1. Equal to 0, it is 0. And for x greater than 0, the function is modulus of x minus 1. For the other function, if you take any number which is less than 0, the function is same. So for all the numbers, if you take the point x is 0, if you take all the for all the numbers less than 0, the function is modulus of x plus 1. For all the numbers greater than 1, it is modulus of x minus 1. So only at x is equal to 0, the function is deviating, isn't it? There is a change happening here. Here it is modulus of x plus 1, here it is modulus of x minus 1. So whenever a function is splitted, you check that the splitted point. At this point, whether the limit exists. Okay, at the splitted point, you find whether the limit exists. Is it clear? We want to find the limit extending to 0. Is it exists? That's what we are going to do. At x is equal to 0, we are selecting x is equal to 0 because the function is, if you look at the function, for x less than 0, the function it is 2, we are dividing that function. For less than x 0, we are taking another function. When x is greater than 0, some other function. So based on the value, when x is less than 0 or greater than 0, we are selecting the function. So at x is equal to 0, we have to check whether the limit is there or not. So this function f of x, look at the function here, f of x is equal to modulus of x plus 1 if x is less than 0, 0 if x is 0, and modulus of x minus 1 if x is greater than 0. So this function, we can rewrite it as f of x is equal to, when x is less than 0, what we know about modulus of x? When x is less than 0, what is modulus of x? It is negative x plus 1. Is it correct? When x is less than 0, negative, modulus of x is minus x plus 1 if x is less than 0. And 0 if it is 0. And when it is greater than 0, it is modulus of x minus 1. We know that when x is greater than 0, modulus of x is x. So I'm writing this as x minus 1 if x is greater than 0. Up to this, is it okay, children? Is it clear? Why
Yes, ma'am.
I am writing like this, is it clear? For less than 0, modulus of x is negative x. If we take x greater than 0, if it is plus x. So we are rewriting the function like this. Now find out the limit. So I am going to find out the left hand limit at 0. So that is same as limit x tending to 0 minus of f of x. Limit x tending to 0 minus of f of x. So less than 0, what is the function here? If it is less than 0, what is the function? This minus x plus 1, isn't it? For less than 0, the function is minus x plus 1. 0 minus means we are taking a number which is less than 0, closer to 0, but it is less than 0. So when you put x as 0, so we will get 1. Now take the right hand limit. What is the right hand limit at 0? Right hand limit at 0 means we will be denoting this as limit x tending to 0 plus of f of x. Limit x tending to 0 plus of f of x for greater than 0. For greater than 0, what is the function here? When x is greater than 0, the function is x minus 1. So when you put x is 0, we will get minus 1. So we will get left hand limit is not equal to right hand limit. So limit x tending to 0 of f of x does not exist. So at x is equal to 0, limit does not exist. So limit exists for all the real numbers except 0. So we are able to find the limit for all the real numbers except 0. Is it clear? So we can find the limit. We can find the limit for all the values except 0. Is it okay? Is it okay, children?
Yes, ma'am.
Okay. Okay. Write the next one. Write one more question. Evaluate. Next model we are going to discuss is an important question. Write down the next one. Limit extending to 0. Children, someone's audio is we are hearing it again. Okay, so mute it. Limit extending to 0. Root of 2 plus x minus root 2 by x. This is a different question and this model is again an important question. How to do this? What is the initial step? We will put the values for x, isn't it? We put the value for x, what you will get? So will you be getting in the
form.
yes, indeterminate form, 0 by 0 form. Here it is not a polynomial, so we can't factorize it. Now here we have root, isn't it? What we can do? So this is the second model, finding the limit by rationalization. What we are going to do? We want to remove the root. So I'm going to multiply and divide by the conjugate. What is done by conjugate? This one we have learned in 9th standard. What is the conjugate of 2 plus root 3?
2 minus root.
2 minus root.
We'll multiply and divide by the opposite sign, isn't it? 2 minus root 3. Likewise here, I'm going to multiply and divide it by 2 plus root x plus root 2 by root of 2 plus x plus root 2. Here we have minus sign. I want to remove this root. So what I'm doing here, multiply and divide by the conjugate. I'm multiplying and dividing by root of 2 plus x plus root 2 by root of 2 plus x plus root 2. So then look at the numerator. So the numerator, it takes the form. In which form? What is the form here?
A square minus b square.
Very good. It is. Okay, it takes the form a square minus b square because it is in the form a plus b into a minus b. So it is root of 2 minus root 2 square by denominator it is x into root of 2 plus x plus root 2. So this is same as limit x tending to 0, root and square will get cancelled. So we'll get 2 plus x minus 2 by x into root of 2 plus x plus root 2. Now what happens? Tell me what is the next step? Plus 2 minus 2, will it get cancelled? So we will get, yes. So limit x tending to 0, x by x into root of 2 plus x plus root 2. Now x will get cancelled. So we'll get limit x tends to 0, 1 by root of 2 plus x plus root 2. Now you substitute x as 0. Now substitute x is 0. So when x is 0, what is the answer? When you put x is 0, 1 by root of 2 plus 0 plus root 2, which is same as 1 by root 2 plus root 2, which is 1 by 2 root 2. Is it okay, Aishwarya?
Yes, ma'am.
Okay. So whenever we get a question in this root form, what we can do? To remove the root, you multiply and divide by the conjugates. Okay, any doubt in the previous question?
No, ma'am.
No. Okay, I think we can wind up this session with this. We can stop. Okay, learn the formulas and then one more